Picture yourself floating in the vast emptiness of space. The silence is absolute, broken only by the soft hum of your spacesuit's life support system. Stars glitter like diamonds scattered across black velvet, but your eyes are fixed on something else entirely. A massive void in the fabric of space itself, darker than the darkest night you've ever seen. This is your first glimpse of a black hole. The massive object ahead of you isn't just dark, it's an absence, a cosmic shadow that devours even light itself. Around its edges, stars appear to dance and twist, their light bending impossibly as space itself warps around this cosmic giant. Your hands, enclosed in the thick material of your spacesuit gloves, grip the edges of your spacecraft's viewport. The temperature gauge reads normal, but somehow, looking at that vast emptiness makes you feel cold. As your ship drifts closer, the first effects become apparent. Time itself begins to play tricks on you. You check your watch, a simple digital display that's synchronized with Earth time. But something strange is happening. While only minutes seem to pass for you, the readout showing Earth time is accelerating. Hours slip by on Earth while you experience mere moments. This isn't science fiction. It's Einstein's relativity in action, as real as the ground beneath your feet back home. The event horizon looms ahead, that infamous point of no return. It's not a physical barrier you can touch or see. There's no sign that reads, "Warning point of no return." Instead, it's an invisible boundary where the black hole's gravitational pull becomes so strong that nothing, not even light itself, can escape. But here's where things get truly strange. As you cross this threshold, you wouldn't immediately notice anything dramatic. No alarms would sound, no sudden pain. The stars behind you would still be visible, though increasingly redshifted, stretching from white to yellow to red as light struggles against the immense gravitational pull. Your instruments would continue functioning, at least for now. Yet something profound has changed. Every signal you try to send home, every radio wave, every light beam, falls back like a stone thrown upward that can never reach the top. You are now in a realm where space and time behave like a river flowing over a waterfall. All paths lead to one destination, and that destination is downward. The real horror show begins as you approach the heart of the black hole. Remember those science class demonstrations with a stretched rubber sheet? Your body is about to experience something similar, but far more extreme. The gravitational force becomes so intense that it stretches you vertically while squeezing you horizontally, a process scientists have dubbed Spaghettification, with a touch of dark humor. First, you'd feel a slight stretching sensation, as if your feet were being pulled more strongly than your head. This force would gradually increase until it becomes impossible to ignore. Your bones, muscles, and organs would begin to elongate. The pressure would build until even the atomic bonds holding your body together begin to strain. In a smaller black hole, this process would happen quickly, perhaps too quickly to fully comprehend. But in a supermassive black hole, like the one at the center of our galaxy, you might remain conscious long enough to experience these bizarre sensations. Your body would stretch like cosmic taffy, atoms streaming out in a long, thin line. A final, elegant transformation into a string of elementary particles. At the center lies the singularity, a point where our current physics breaks down completely. All our equations fail, all our models crumble. It's a place where space and time cease to have any meaningful definition. Some theorists suggest it might be a portal to another universe. Others believe it's the ultimate dead end. The truth is, we don't know. And anyone who's gone to find out hasn't been able to report back. The most fascinating part, while all this is happening to you, an observer watching from a safe distance would see something completely different. Thanks to the extreme warping of space-time, they would see you appear to slow down as you approach the event horizon, moving more and more slowly until you seem to freeze in place. Your image would gradually fade to red, then disappear entirely, like a cosmic version of the Cheshire Cat's grin. Is there any way to survive this cosmic water slide? Current physics says no, at least not in any form we'd recognize as survival. But black holes have surprised us before. They exist at the boundary of our understanding, where the laws of physics as we know them begin to break down. In the end, a journey into a black hole represents the ultimate adventure, a one-way trip to the edge of reality itself. It's a journey that would transform you, quite literally, while revealing some of the deepest mysteries of our universe. The fact that such places exist, that they follow rules we can partially understand, yet still harbor such profound mysteries, shows us just how remarkable our universe truly is. And perhaps that's the most incredible part of this story. You don't need to actually fall into a black hole to be transformed by it. Just contemplating these cosmic giants, understanding what they tell us about the nature of space, time, and our own existence in this vast universe can change how you see everything around you. After all, we're all falling through space-time together, dancing on the edge of mysteries we're only beginning to understand. If you enjoyed this cosmic journey, don't forget to hit that like button. It helps other space enthusiasts find this video. And if you want to explore more mind-blowing space phenomena, subscribe to the channel and hit the notification bell. Let me know in the comments, what other cosmic mysteries would you like me to explain? Until next time, keep looking up and wondering about the mysteries of our universe.